your combination. So we are having 4 terms, right? Alpha, beta, gamma, and delta. So basically what we have is 4 combination 1, 4 combination 2, 4 combination 3, and 4 combination 4. 4 combination 1 means out of these 4, take them one at a time. There are 4 of them. 4 different terms. So this is 4. This will be 6 by calculation. You agree? Remember that? And that's why this will be 6 in altogether. So if you don't add up to 6, then you should know something is wrong. Okay? 4 combination 3 is the same as 4 combination 1, which is 4. Yeah? So this is also 4. You can see that. 1, 2, 3, and this is the last one. And 4 combination 4 is also 4 combination 0, which is 1. And that's why we have 1. So if you can link this sometimes, you'll be able to see if something is missing or not. So let's write the answer. Yes, tell me what this will be now. Alpha plus beta plus gamma plus delta x cubed. Yes? Then this is plus. Then I have combination of 2. Alpha, beta, alpha, gamma, alpha, delta. Then I don't need to do beta, alpha again. That's also alpha, beta. Look at it this way. Alpha, beta, gamma, and delta. So I will have alpha of all this. Beta doesn't need to go back. Beta with this, beta with that. Okay? Gamma doesn't need to go back because it's repetition. So gamma and delta, and that's it. So it's going to be beta what? Beta gamma, beta delta, then gamma delta, and that's it. And this is for x squared. Yeah? For the x, there are 3 in number. Permit me to write that on the next line. So minus the combination of 3, alpha, beta, gamma, alpha, beta, delta, right? Yes? Then I have alpha, gamma, delta. There's one more, right? What's that? Beta, gamma, delta. And this is x. And the constant term will be alpha, beta, gamma, and delta. And that's it. Okay? A lot of you got this right. I'm just trying to make you see the patterns and connect it to a previous topic. Okay? Now, the next thing is, for each of these, write down the sum and product of root. In the next question, I do not expect anything complicated. Just pick the first one. What are the sum of root and product of root? That's all. For f2x, sum, there are just 2 of them. Product, alpha, beta. That's all I asked you to do. A lot of you were trying to bring in, oh, maybe it's too easy for Mr. Daniel's question. No. Because I want you to link it. This is actually not in your book. The other questions are in your book. I want you to, this is just to help you connect it in number 4. That's the reason I have this. Okay? So for F3, I'm just writing this side by side. I do not encourage that, please. For F3, x, our sum will be alpha plus beta plus gamma, and the products will just be alpha, beta, gamma. And for F4, the sum will be alpha plus beta plus gamma plus delta, while the product is alpha, beta, gamma, delta. That's all about number 2. Number 3 says, for each of these functions, compare the constant term with the product of the roots. Compare the constant term to the product of the roots. Okay? So the first one, let's compare the constant terms. The constant in the first one is A alpha beta, right? Compare with the product. So a lot of you wrote, look at the second, before we even jump into that. Second one is minus with the product. In the third one, it is so, which means there is no fixed pattern, right? It's changing a little bit. So that's why some of you wrote it separately, which is good. For F2, yeah? For F2, the constant term is A multiplied by the product. Okay, something like that. Or maybe before this, like some of you did, you wrote out the constant term first. Then you wrote what that implies. If I may share this space. So you have A alpha beta, which means A times product of roots. I just write products. Okay. By product, I mean product of roots. For F3, constant term is negative. So somebody missed out the negative here. Alpha, beta, gamma, which simply means minus A times the product. And for F4, the constant term is simply A, alpha, beta, gamma, delta, which is A without minus again, times the product. And the next thing is to compare the x to the power n term, n minus 1 term. X to the power n minus 1 term means the second term, right? If you arrange it in descending powers of x. Hello, what's the problem? If you arrange it in descending powers of x, you are one of those who request this. This is not the time to sleep in the class, sir. Is it the end of the first one already? You can walk around. Because I have something else planned and I don't want to, break the class. So, so quickly, I think this, for this one, it's the same for the second term, right? Okay, for F2x, okay, coefficient of x to the power n minus 1. Instead of x to the power n minus 1, I'm just going to say coefficient of x. Agree? Because that is the n minus 1 in this case. Coefficient of x is what? Look at it. Coefficient of x is A multiplied by this. So that's negative A alpha plus beta. Okay? And for F3, the coefficient of x squared now is negative A alpha plus beta plus gamma. For F4, the coefficient of x cubed now is negative A alpha plus beta plus gamma plus delta. So it is from this observation that you have to make the conclusion. I'm trying to save time, but you know what I meant there. Question 4, which is the main observation. Question 4 now says, generalize your observation for a polynomial of degree n. How did I construct that again? Generalize the observation in question 3 for polynomial equation. So this is a polynomial equation. Sigma r from 0 to n, a to power r, ar x raised to power r is equal to 0, right? Which in expanded form simply means a0 plus a1x plus a2x squared and up to anxn. So this is a polynomial equation of degree n. Okay? So to make it look like that, I'm going to arrange it in descending powers of x. So an xn, an minus 1, xn minus 1, an minus 2, x to the power n minus 2, and this continues until a2x squared, a1x, then a naught is equal to 0. So this is a polynomial of degree n, where an is not equal to 0, of course. Okay? We want to generalize. It's easy. Now look, I'm sure you did it already. If you look at this, this is actually the coefficient of xn minus 1, right? Coefficient of xn minus 1. That's where this comes from. In all of them, there is a minus a, right? Multiplied by sum of roots. Yes? And this coefficient of xn minus 1 is what from here? an minus 1. Now, this a is what? This a is the coefficient of the first term. Do you agree? Which in this generalization is what? An. Do you agree with me? Leading coefficient. Understood? So this means, okay, this means negative an times sum of roots equals an minus 1. And that is where you can conclude sum of roots in general will be negative an minus 1 divided by an. So it is the negation of this coefficient of the second term divided by the coefficient of the first term. So without solving the polynomial, you can actually get the sum of the roots. That's the point we're trying to make here. I'm sure some of you remember quadratic. Sum of roots is minus b over a. It's just the simpler version of this one. Understood, sir? Do you agree this is this? A is this, right? If this was expanded, that is ax to the power 4. And this is a polynomial of degree 4. So this is the an. That's the a4. The same a here is the leading coefficient in Q. Is the leading coefficient in square. So in the general polynomial, it is actually the an. That's why I rearrange it. So this a is an. Understood now? And it's just solve the equation, kind of. So also from the constant term, if you look at the observation here, the constant term here is, where is it? Okay, we can look at it from here. This is enough to